Hi everybody, it's Mr. Defy. This video is about how to derive the law of cosines and how to use it. I have two examples coming up after the derivation. So here we have a blank triangle, ABC, with sides ABC. And in order to derive the law of cosines, you have to first start by drawing an altitude. So there it is. I labeled my altitude H because altitude, height of the triangle. If you look at the bottom, segment AB is also called C, and C is exactly opposite of angle C. So we're going to use that to our advantage here. So what I'm going to do is I'm going to try to represent this length as now two divided lengths. So C represents the total length from A to B, but because of our altitude, it's now been segmented into AD and DB. So I need to give AD a new variable to represent its length, and I'm going to call that x. Okay. I also need to give a new label for segment DB, and I'm going to call that the difference between C and x, or in other words, C minus x. Okay, so that now represents a smaller triangle. Now, to derive the law of cosines, you start with a simple relationship. And we're going to focus on angle A here, since this belongs to the larger of the two smaller triangles. So I'm going to say that the cosine of angle A, and again, I'm using cosine because this is about the law of cosines. So the cosine of angle A, our focus angle, is equal to the adjacent, which is x, over the hypotenuse, which is b. If I were to solve for this, what I would get is that x is equal to b cosine of A. Okay, now it's important to remember this because we will need to go back and use this later on. So I'm going to highlight it there. Okay, that also reminds myself, hey, I need to go back and look at that later on. So x is equal to b cosine of A. Now, there are other relationships that we can use. Involving right triangles, we always have to consider the possibility that the Pythagoras Theorem could be applied. And in this case, it can indeed be applied. So take a look over here. With the bigger of the two triangles, which is, by the way, this one over here. This is the one I'm looking at right now. So with the bigger of the two triangles, what I can do is set up this relationship to show the connection between all three of these sides. And that would be the following. It would say that x squared plus h squared is equal to b squared. Now, if I solve this for h squared, what I get is that h squared is then equal to b squared minus x squared. Okay, again, something that I will need to go back and look at later on. So I'm going to highlight it as a reminder for myself. What I also see is that this smaller triangle, which is over here, this smaller triangle is also a right triangle. And so because of that, I can also use the Pythagorean theorem for that. And it would be something like this. It would say that c minus x squared, because that's the whole leg down there, plus h squared is equal to a squared. Now, with this, I need to expand c minus x squared. But I'll do that later. What I want to do at the moment is I want to solve this for h squared. So I'm going to say h squared is equal to a squared minus the quantity c minus x squared. C minus x squared. Okay? And then I can continue by breaking this down. So h squared is equal to a squared minus, if you expand c minus x squared, that binomial becomes the following. It becomes c squared minus 2cx, or minus 2xc, however you want to write that, plus x squared. Okay, when you apply the negative inside, what you get is h squared is equal to a squared minus c squared plus 2cx minus x squared. And again, I just isolated my h, and so this is something that I will need to go back and use later. Okay, so as a reminder to myself. So what I have over here is I have three relationships based on this triangle. Now, two of these involve h squares being isolated. That would be these two over here. Okay, h squares are alone. So what I'm going to do is, since they both equal h squared, then I'm going to make them equal each other. And I'm going to rewrite it in this way. I'm going to say that a squared minus c squared plus 2cx minus x squared, that whole thing is equal to b squared minus x squared. Okay, I'm tying them together. And when you think about eliminating or solving equations, you have to remember what you do to one side, you do to the other, right? So these two, oops, why didn't it show? These two will eliminate each other. When you add x squared on both sides, they both cancel out. So they're no longer there. And so what I have now is a squared minus c squared plus 2cx is equal to b squared. Now that b squared is pretty lonely on that side. So what I'm going to do is I'm going to solve this for a squared. Remember, our focus angle is a. Because it's a, then we want to have that corresponding side opposite of angle A. We want to have that reflected in our equation over here. So I'm going to solve all this so that a squared is isolated instead of the b squared. So when I do that, I'm going to do this in one big step. Okay, so when I do that, all this will get pushed over there. And what I get as a result is a squared is equal to b squared plus c squared minus 2cx. Okay? Now, we have to go back even further. Remember, way at the beginning, we made this relationship about our x being equal to b cosine of a. That's right over here. Right over there. Right? Our x is equal to b cosine of a. Well, this now kicks in because I can substitute this all the way for my x over here. And when I rewrite that, I get the following. Check this out. I get a squared is equal to b squared plus c squared minus 2c b cosine of a. And there you have it, folks. We just derived one of the laws of cosines. Ta-da! Now, one thing I want you to note about this is the following. And I'll use my highlighter so you can see it. My side is A. You see that? I highlighted that in yellow. And my focus angle is A. They will always be corresponding to each other. Whatever your side is on this side will be your focus angle on that side. Okay? And it always has to be like that. And if you notice also, B and C appearing here are also right there, B and C. Okay, so I'll highlight that in blue so you can see that better. So B and C are also B and C. And so the way that you use this is your unknown will either be whatever's highlighted in yellow. So you'll either have your unknown being a side or your unknown being an angle measurement. And if that's the case, then whatever's highlighted in green will be information that you do know. So in this case, I either don't know my side or my angle A, which means that I do need to know what my length of B, my length of C are, and I also need to know what my length of B and C are for here, okay? So with that in mind, there are three different possible ways to write the laws of cosines, and they are this. Three ways to write the laws of cosines. The first way is like this. You could say what I have over here, which is a squared is equal to b squared plus c squared minus 2cb cosine A. But the other possibility is if your focus side or angle is b squared, then you would need to know your A and your C. That would mean that A and C are here also, and you would have cosine of the angle B. And the third possibility would be if you need to figure out your side C, for example, then you would need your b squared, you need your a squared, you need your a and your b, and your angle, your focus angle would be C. Okay, so I hope this helped you out. Memorizing all three of these is not something that I advise. What I recommend instead is that you try to understand the relationship going on here. And so if you need to stop by, if you need to rewind and watch this again, please do so. I did say that I would give some examples. However, I think I'd rather do that in my next video after this, and this would be just a standalone on how to derive the law of cosines. So I hope this helped you out. Please stop by, leave a comment, and as always, thanks for taking the time to watch. Bye-bye.